So in this video, we're going to look at the list monad. We're going to look at the list monad transformer. Okay, so that's the title for today's video. And in my previous videos on transformers, monad transformers, we looked at the simple monad transformer, which was we created a new type, maybe T, and we're going to use some of the same bases in this video, where we're going to declare a wrapper. So the first thing we're going to do in this video is let's first, before getting an introduction to the list monad transformer, let's first create a wrapper. So I'm going to use my new type. I'm going to use a new type in Haskell. I'm going to use a new type in Haskell to create a wrapper. And I'm just going to call this as my list T M A, and this is equal to, well, list T, you can think of list T over here acting as my type constructor. List T is acting as my type constructor, and this is equal to the value constructors, which is list T, and it has one field, and let's call this field as list, run list T. Okay. And what we're going to do now is we're just going to take some of the obvious things that we can at least infer from this type, type definition. So one of the things that I at least know from this statement here is that if I were to look at the type signature for my value constructor list T, I know that list T, my value constructor, has a following type signature. It takes in some value of the following type, and that's my input. This is my input argument, and it gives me back some value of type list T M A. Okay, so this is my type signature for the value constructor list of T. And likewise, if I write the value signature for my method run list T, it takes in some value of type list T M A, and gives me back some value of the type M of A. Okay. So this is just the some of the just some of the obvious that I can at least infer from the following new type definition of my list TMA. Okay, now what I'm going to do is I'm just going to look at the type class of my monad, which is this is a type class of my monad, and what I know from the type class of the monad is that if M is going to, in this case, M over here is a monad, so I have my M in this type class acting as a monad, and these are the type signature for the bind method. This is for the bind method over here, and this is a type signature for the return method. And at least for this video, I'm going to stress more on the bind and on the return method when we think about making list TM as an instance of the monad's type class. So given this type class definition, what I would like to do now is I would like to use this type. I would like to create an instance of the monad's type class. So what I'm going to do now here is let's just look at maybe the returns type signature. So if I look at returns type signature here, I note that A over here has a kind. It has a kind which happens to be a concrete type, and MA also has a concrete type. It's a concrete type, meaning the kind for MA is also a star. M on the other hand has a kind. It has a kind where it takes in a concrete type and gives you back as an output another concrete type. That's the kind for M. So M in this case has the following kind signature. Okay, given my new type definition over here, can I infer what is the kind for M going to be and what's the kind for A going to be, and likewise, knowing that, can I infer then the kind for list T? Okay, So again, from here, what I know is that the kind signature for m of square bracket a square bracket close, the entire thing has a concrete type. This is represented by a star. Likewise, list TMA also is something that has a concrete type. And likewise, this entire thing has a concrete type, and I know that list TMA also has a concrete type here. M on the other hand, I can easily infer over here is something that takes in a concrete type and gives you back another concrete type. So that's the kind signature for M. And likewise, if I look at A here, A is something that can be easily assumed that it has a concrete type, because if I look at my type constructor for my list here, the type constructor for the list is something that takes in a concrete type and gives you back another concrete type, and I'm just using the type constructor for the list to infer that the kind for A is something that also happens to be a star. So what's the kind for list T then? For list T, for list T, the kind for list T in this case is it consumes these two parameters M and A, and the kind for M is it goes from a star to a star. That's for M. For A, for A, the kind signature is a star, and as an output, I get back another concrete type, which is represented by this star. Okay, so if I would like to make an instance of the type class monad, what's important here is that I obey this kind signature. I must not deviate from that kind signature. So what I need to do is, given this kind signature for the list T, I need to partially apply it and keep on applying it to the point where I can exactly match the kind signature for M in the monads type class. And it's quite obvious that this entire thing must be partially applied. I must apply this entire piece over here, so that when this entire piece gets applied, what is remaining is from a star to a star, which is going to match the kind signature for my M. Okay, so how do I do that? So I'm going to take list T, I'm going to take my list T, and I'm going to pass in the type variable, in this case M. List T of M, where this entire piece over here is my M, is going to have the following kind signature going from a star to a star. So now I can make the following, I can make this following an instance of the monads type class. Okay, so this is the first thing I'm going to do, and in order to do this, what I'm going to do now is I'm just going to redefine or in other words, I'm just going to implement the return method or the return statement, and I'm going to implement the implementation to the bind method in the list tm, which is going to be an instance of the monads type class. And I'm going to do this in my next video.